So welcome back guys. Already explained you that electric field is conservative. That means work done by the electric field in the round trip is zero. So that example I have given like this in previously. So the path OPQ or PQR, however you take, the work done along this path zero means it is conservative. If not zero means it is electric field is not conservative. So in this the electric field is not zero, we will get. So from the given E direction. So now in this case, so from A to B or 1 to 2, the work done, and 2 to 1 along this path, the V1, V2 minus V1 and V1 minus V2 both are equal and work done will become 0. So this will be conservative. Here in the electric field is conservative. Yeah, in this case. So for non-conservative, electric field is non-conservative. For that, I will give one more example. See, consider electric field, uniform electric field in this region. So this is representing uniform electric field. So lines should be straight and the gap between the lines is same. Here the E is not equal to 0. So but surrounding medium, so here in this field, in this region E is 0. So in this region also E is 0. Electric field is 0 in this region. Now consider one closed loop. So which is like this. So ABCD closed loop. ABCD is a closed loop. So the work done is moving a charge from A to B, B to C, C to D, and A to D to A. In this is 0 or not, we will check. So here if you see clearly, work done from B to C is equal to 0 since E is equal to 0 in this region. So now work done from C to D is also 0 because here E and the R are perpendicular. E perpendicular to R means the line dr, the position vector C to D is perpendicular to E direction. So that's why potential is or work done is 0. So similarly, the work done A to B also 0. That is, here also E is the direction of E is perpendicular to R bar, AB bar. R bar means AB bar. Work done is 0. But whereas in case of A to D or D to A, here arrow mark is A to D is given. So now their work done is equal to integral E bar dot dl, potential E bar dot dl into Q. You can have to take potential into Q, work done. Potential is E dot dl. So therefore here work done is equal to E into L, E or QE into L. So which is not equal to 0. That means in this case, here this electric field is non-conservative in this case. So I hope you understand this. So another example we will find out, that is, so V is varying with respect to x potential. So V is given is a function of in terms of x V. The given V is 2x plus, next question, 2x plus 3y minus z. So now electric field is how much? Electric field due to this potential, given potential function. So we know electric field is equal to minus negative gradient of dv by dr. That equal to, I can write minus of dv by dx I cap plus dv by dy j cap plus dv by dz k cap. Because E is a vector and dv by dx is field formula, right? Means potential in terms of field. Means negative gradient of potential is called field. So now, so here in the place of phi, first I will do x, that equal to minus of 2y cap plus 3j cap minus 1k cap. So what is this? Derivation I am doing v function. So then I will get e value. So now magnitude of e bar is equal to. So this minus will not come, then magnitude means. So that equal root over 2 square plus 3 square plus 1. So that is root 4 plus 9 plus 1, that equal to root 14. That equal to 3.7416. Rounding off to 2 decimals, 3.74. Maximum will ask in advance. 3.2 2 decimals round off only. In mains, there sometimes they will ask nearest integer. Like that. So next model of the problem we'll see. So in the next model of the problem, so here E they have given. So next question. So E is equal to, they are given in vector form. E is equal to 2axy I cap plus 2 into a into x square minus y square j cap. So this is given electric field, the vector form of electric field with x and y variable, a is constant. So now from this given electric field, variable electric field, how to find out the potential? Then potential is equal to question mark. So initially the potential is V naught. So now we know dV is equal to means electric potential is equal to E bar dot D bar. So here dr bar is equal to, I can write dx I cap plus dy j cap plus dz k cap, but here ij only, the electric field lies in xy plane only, ij only. That's why r bar vector also you can take like this. So now that is equal to integral dv from v naught to v. So is equal to integral e bar dot d bar, dr. So limit is not given here. So now that equal to, so 2ax y into dx integral plus integral a into x square minus y square into dy. Means in the dot product, I dot I is 1, the remaining dot products are 0, j dot j is 1. Because parallel vectors mean dot product will be exist and perpendicularly vectors are there, dot product is 0. The dot product between the perpendicular vectors is 0. This angle is 90. So now here this is integration after the V minus V naught is equal to, and the people know then dV is equal to minus of, means dV is equal to work done by the external agent, that is minus. If work done by the field means the plus will come. So this minus and plus only indicates the knowing that work done is by external agent or electric field. The problem that is equal to, now here dx that equal to 2ay is constant. X dx we are doing means we will get x square by 2. This is minus of, minus everywhere you consider, plus. So here again summation rule you have to apply. A into x square integral only dy means y will come, minus a into y square dy means integration of power rule y cube, a into y cube by 3. So that equal to v is equal to v naught, 2 get cancelled here, minus ax square y, minus ax square means here I can go with this 2 get cancelled here, minus ax square y, here also minus x square y, that is equal to 2 ax square y, minus some minus into minus plus a y cube by 3. So this is required potential. Potential is a scalar, we know. So there is no I and j components. It will be scalar. Simply you can add that. So next, coming into another question, another model. So for example, so the electric field is given means, so this is xy axis. So here one point B is there. So here one point A is there. So this is origin. So now field lines are in the xy plane. The uniform field is acting in along the xy plane direction. So along xy plane direction like this. So uniform electric field. The value of electric field is equal to 100 volt by meters, because V by D na volt by meter. 100 volt by meters with some angle theta is equal to 30 degrees it is acting. And here OB they have given, OB is equal to, the distance of OB is equal to 4 meters. That I can write vector form 4 into j cap. Why I am writing 4 into j cap, you will understand. And here AO or OA is equal to, they have given 2 meters. So then OA bar is equal to 3 I cap. AO bar is from field. Here also 30 degrees only. Here also 30 degrees. So now here in this case, for 2 methods I can solve. Method 1 I will see first. In method 1 what I will do means I will resolve the E component to X. So E bar is equal to, I will take EX I cap plus EY j cap. So that is equal to, so EX means what? Here EX, X, this is E100, hypotenuse is 100 now, EX is cos 30 and EY is sin 30. Therefore, E bar is equal to, will become E cos 30 I cap plus E sin 30 j cap. Similarly, means that is E is equal to 100 already given. Cos 30 means root 3. Therefore, 50 root 3 I cap plus 50 j cap. So this is E value. I resolved into E, X and Y. So now here dr bar is given. Dr bar is equal to 2 I cap plus 4 j cap. So he has given dr bar. Therefore, potential is equal to, is asking potential to find. So E bar dot dr bar. So that equal to 100 root 3. So this is potential is negative integral of E bar dot d bar that equal to 100 root 3 minus 100 root 3. So here 4 into pi plus 200, 200. So that equal to here 100 take common, root 3 plus 2. So this is given answer. That's why we are getting like this. Otherwise 200 plus 173.4 that equal to 373.2 also they will give minus 373.2 is also answer potential. But they have given like this, so we are going like this, right? So this is one method. So coming into second method. So if you see another model, and means in this only second method I will explain. So coming into method 2. So this is in some cases it will be helpful or in the next problem. So from the diagram what you can see means, so resolve the distances in direction of electric field. Distances in the direction of electric field, right? So this is electric field direction. So here 2 meters is there, here 4 meters is there. So resolve the 2 meters along field direction. So this is 30 degrees given. So right angle here. So this will become 60 degrees. Resolve the 64 meters also, 4 meters vector also into field direction. So that means the dr bar will become now 2, means 2 is hypotenuse, and resolve the components into perpendicular. So the perpendicular component will be 0. E dot dr, the angle between dr and E is 90, means perpendicular component is 0. So here 2 means 2 into cos 30, 2 into cos 30. So this is this direction x cap we consider, and this direction is y cap we will take. So now 2 into cos 30 I cap plus, now so in this direction E is x I cap is given. So now next one 4 into cos 60, so I cap. So now that is cos 30 is root 3 by 2, that equal to root 3 plus cos 60 is 1 by 2, that equal to 2 of I cap. And E direction also I cap only I consider, therefore E bar is equal to 100 I cap. So therefore potential is equal to minus of E bar dot dr bar. So that is equal to minus 100 I cap. I cancel means root 3 plus 2. So this is another mode. So now next question we'll see. So take next question. So next model of the question. So they have given x and y axis. So this is the question related to equipotential term. So now here this is x axis. Here is the y axis. So that is x axis. Here distances are there 10 meters, 10, 20, 30 centimeters these are, and 40 centimeters. So there is equipotential surfaces they have given. So equipotential surfaces, sorry. Right. Hmm. So 10 volts. This is equipotential surface, and this is 20 volts, and this is 30 volts, and 40 volts. The difference between each surface is also same, 10, 10, 10, 10. and on this line anywhere the field potential is 10 only. So for equipotential lines, this is the line representing the equipotential, means the field will act perpendicular to this line, right? So this is the direction of field. So field compulsory will act perpendicular to this field. Perpendicularly will act field. But here you can see, so here given angle is 30 between the x-axis and equipotential surface. Everywhere 30 is given, and this distance will become 10. Now if we see here 40, 30, 20, 10, that means from right to left the potential is, means in this direction potential is decreasing, therefore field act in this direction. So here point one note you have to consider, that is in the direction of field, in direction of electric field, potential always decreases. This is the very important note. Potential always decreases. So that is the reason. See, once if we see, we know in the battery there is a two terminals are there. One is positive, another one is negative. And you will tell positive terminal has more potential. V positive is more than V negative. Why means? So field from the positive terminal is like this. From the negative terminal is like this. To the negative terminal it will be attractive. For the positive terminal it will be away. So here see, when I am moving from positive terminal to, this is the field direction. Here E bar. That means field direction is from positive to negative. This is conventional current direction also in the cells. So that will be other topic, right? So now potential is decreases from V positive to V negative. So therefore negative terminal is negative terminal is less potential than positive potential. That is why in the battery they will mention positive and negative like this. So different lines. One is bigger one and another one is smaller one in the cell. The reason is this terminal have more potential, right? So now here potential is decreasing in the direction. So and field is act perpendicular to the equipotential surfaces. Already this is in part 1 class I explained. So E is in the direction. So and this is the dr bar, dr 10. The angle between the field is here. Angle between field and dr is 120. So theta is equal to 120 degrees. So now I need to find out the electric field here. Electric field I don't know. Direction I find out, and angle also find out. Direction I find by knowing the values of potentials, decreasing direction of potential. So potential decreases in the direction of electric field, and here electric field is perpendicular to this potential line, because these potential lines mentioned as equipotential lines. Now, so here field I need to find out. So to find out field, so here I know already E is equal to, the formula for E is equal to dV by negative gradient of dV by dr. That means V is equal to E dot dr. Means E dot dr means this dr is parallel or some angle, not perpendicular, right? So now this dr value 10 centimeter is resolved into electric field direction. Now this is hypotenuse. This dr value is hypotenuse. So resolve into along the electric field. That means perpendicular distance for equipotential surface. Perpendicular distance. This is the distance perpendicular to equipotential and parallel to electric field, because electric field and equipotentials are perpendicular. See, many times I am repeating these points, remember. So in some other problems, same it will be useful. Now, so here I have to find out the dr value or V by d. That is, here d is equal to perpendicular to equipotential distance or parallel to the along the field direction. So now if we see, so this is 30 and here it is, this is hypotenuse, it is opposite. Here 60, cos 60 or sin 30 both are same. Therefore, D is equal to 10 sin 30 or cos 60 into 10 power minus 12. That is equal to meters. Means given here 10 centimeter, convert into meter. Therefore, E is equal to, the magnitude of E is equal to, so V is how much here? 10 by 10 into 1 by 2 into 10 power minus 2. That equal to 10 get cancelled. So this 2 and 10 power minus 2 will go up, means 200 volt by meters. Electric field V by D. Newton by Coulomb also you can write. So this is another model from the equipotential surface. Here also see this method 2, method 1 also resolving the E into x axis and y axis or R into x axis and y axis, because dot product V is equal to dot product of E and dr. So perpendicular distances will give 0 potential, or perpendicular field to the length is 0 potential. The remaining length means parallel or some other angle length will be give the answer potential value. So next model. So here itself I will explain simple model. So next model of question. So if I want to tell about each and every model on potential, only 1 month or 10 classes will happen. So that's why I am trying to give only some important models and which is useful to solve all. So this is the equilateral triangle upside 2 meters. So consider a field horizontal to this, means like this. Field lines are in the direction like this, to the surface like this. These are field directions. So equilateral side means this is angle 60. Either resolve the distance along the field or field along the distance. So now V is equal to minus of, so E bar dot D bar. So here already R is 2 meters along this direction. So in the direction E resolve into components. So this is also 60 will come. So that is equal to minus of E bar means Ex. Why perpendicular? The field is perpendicular and to the length, then potentially 0 due to perpendicular. Only along this direction I will consider, that is equal to Ex into 2. So that equal to Ex is equal to here cos 60. So and E value is given something, that is equal to E cos 60 into 2 meters, right? E cos 60 into 2. So that is equal to, I can write E only, cos 60 only. V is equal to E. So values are given means you will get answer, right? So I hope you understand this. So for example, here E is given 10 volt by meter. So then this is equal to minus 10 volt by meter, because potential is, means electric field is negative gradient of potential, and here if you see E and displacement vectors are anti-parallel also. So it will be supported minus 10, answer is minus 10 volt by meters. So this is related to potential problems. So I hope you understand. Thank you all.